down to the bottom and then came up to the top and floated.
Okay. Was it the tank? Did it go down to the bottom of the tank? And what was it floating in?
Oh, it was floating in water.
Okay. So we need to be explicit in our observations, because if I don't know, you need to assume when you're giving your observations, assume nothing. I mean, I know that you mean water, but if I'm writing a dissertation on this, I need to be very clear. So
alcohol.
it could have been alcohol. And air would change things too. So what we're going to do throughout our instruction this week and next week is we're going to make lists of sentence stems, things we can use to scaffold in our writing, because that's 1/3 of the mixed program. There's math, science, and writing. So we're going to try to incorporate this writing piece into our science instruction so we can make it flow and use it as we learn, okay? So let's record 2 things here. The first one is, Teresa, what would the first sentence stem be that we can use?
For your observation?
Or your hypothesis.
Oh, the prediction? I wrote, I think the grapes will sink and the watermelon will float because the watermelon is less dense than the grape.
Okay, so let's include that. I think, and then whatever you thought, because, fill in the blank, okay? And then the second one was related to your observations. It's a comparison. I observed whereas, and this is where the second observation would come in. I observed that the grape sank to the bottom of the water in the tank, whereas the watermelon rose to the top and floated on top of the water in the tank. Okay? So there's 2 things we can put into our toolbox. Okay, now, yeah, sink. I'm going to try to include Spanish. I'm not a Spanish speaker. So if I get these wrong, somebody who is competent, please tell me if I'm wrong. So when something sinks, hundirse? Hundirse. Okay. All right. So we are going to put sink into our vocabulary toolbox, and we're going to put float into our word wall too. Flotar? Yes? Are these right? Okay. Sweet. Now, in my classroom up in Round Rock, I have maybe 2 Spanish speakers in a class. I know that's a little bit different for a lot of y'all. So this is not in my, yes, it is. Maybe it should be. But I typically have more kids that speak Chinese than Spanish. I'm not even going to the Chinese language. Okay, y'all ready? Okay, so we've got sink and float. And now.
For there's sink, you've got it conjugated on the version being right? I would do the verb and just do H-U-N-D-I-R.
Oh, okay.
Conjugation on the
Okay, good. All right, I can make that change. No, I think I did right there.
It's right here. She's talking about on the screen.
Okay, I'll do that. Thank you, Teresa. Okay, so here is a method of writing that you can use. In your language arts classrooms, a lot of times, have y'all heard of the CER method that's used in language arts classrooms? Well, the ACE method, I'm sorry. ACE? Okay. The ACE method is used in English, language arts, and when students are writing, they answer a question, they cite, and then they expand. When we translate this into the science world, it looks like CER. It's the same method, but the language arts people call it one thing, and the science people call it another thing. You make your claim, you back it up with your evidence, and then you provide your reasoning. So if you remember that and apply that to everything that you write, you're gold. But that's it in a nutshell, and we're going to use that this week. So this is what it looks like, or can look like. I think that blah, 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 because, so you're backing it up with the reasoning. And this happened because, so there's a lot of becauses. So this is where you'll do your observations, and then you can tell why. Okay, so spend about 30 seconds to a minute and try to rewrite your prediction and with your observations and your reasoning, your claims, your evidence, and your reasoning with the watermelon and the grape. Put it in this format, and then we're going to share. Okay, so I'm going to give you 1 minute to do that, to do your writing. Just sketch it down real quick. Claim, evidence, and reasoning.
With the partner?
No, this is individual, and then in 30 seconds you will share with your shoulder partner. Yes.
So you're wanting us to make claim evidence and reasoning before we had known what was gonna happen?
No, this is what you do after you're done.
So why would we say?
Because we didn't test certain aspects of this. This is your observations, and then you're bringing in reasoning based on prior knowledge.
So they're trying to explain why that happened.
Yes.
Over there, it says because this happened because
Isn't that like this?
we haven't talked about the explanation yet.
No,
So
we
we've
haven't.
only had our, what we think happened.
Yes.
So,
So you're speculating.
but if
You're
you're
providing
saying
your
this, the
reasoning.
kids, if you write this happens because, they're gonna think that's the answer.
Right.
And so it's gonna be harder for them to unlearn if they did not have the right.
Well, and you would typically do this if you had prior instructions, so they have the foundation to be answering this question.
It's like building up on something.
Yes, you're building on prior knowledge. Elizabeth?
I was just wondering why we wouldn't say, I think that the watermelon floated because, and then the reason why is what I understand.
Okay. Okay, so let's, I'm sorry, I didn't write that very clearly. Okay, so first, what is our claim?
Watermelon float.
Okay, the watermelon would float or sink, okay? What was our evidence?
Well, evidence is like what you see, right? So it's floating.
Okay,
Maybe she said this.
No.
This will happen
Before we put it
because
in the neck.
okay, yes,
happened.
okay. And we don't, that scaffolding, we can adjust it to whatever we need, okay? That's not a hard and fast rule. Just make your claim, support your evidence and your reasoning. So the watermelon floated to the top of the water in the tank. I think the watermelon would float to the top of the water in the
I
tank
thought the watermelon was going to float to the top, and that is what happened.
because,
Because it's less dense in the water.
There's the
Yes.
reasoning, but
But if they don't know
you're
that.
missing the evidence.
well, if they don't know it, then we haven't, if,
Yeah, I guess it wasn't the because.
if they don't have the foundational skills to know the because, this is useless.
They wouldn't do this.
You would not do this until they have the foundational skills.
But this
to
is an
reason.
engaged, and so they wouldn't have the
Yeah, that's what I
background.
But most people in this room have been through several classes of density. So they have the foundational knowledge.
For us.
Yes,
Yeah.
for y'all. I'm sorry.
You're not being the student, technically, right? We're not being
Yeah,
our
we're not being
kids.
Yes, you're not
We're
being your
being like
kids.
as a-
You're being yourself. You are being Jennifer. Be yourself. Yes. Okay. So when we're writing, another thing we need to be very careful about is using pronouns when we're writing. Be explicit. We talked about being explicit about what we observed, that the watermelon rose to the top of the water, not anything else, not to the tank, it rose to the top of the water. And also when we're writing, we need to not try to reduce those pronouns as much as possible so that you are very clear about what you're talking about. So reduce the its and that and all those pronouns so that it is certainly clear to the writer.
So should we say would option?
Well, this is like writing a conclusion. This is post-lab.
So then we're not going back to our hypothesis.
Yes, you are. Okay, we'll hit this a little more later, okay? So I promise this will become more clear as we move on.
But for right now, we need to review just a little bit about our math. Now, last summer, we talked about polygons, polyhedra and non-polyhedra. You remember a polyhedron? Poly means many, and hedra means faces. So polyhedron have many faces, and there is an example of a type of polyhedra. So where is the infamous bucket with names? It helps if I have my glasses on, since I've been there since 2. So Kelly, can you tell me, that was a very poor question because it wasn't telling you if it's a yes or no. Thank you, Kim. Tell me what is the name of this particular polyhedron? Kelly. Take a guess.
Who's Kelly?
Miss Kelly.
That is the question.
I don't know, so I just thought Kelly was a new one. Kelly's gone.
Or no, Kelly?
Tanya.
Tanya, that's cute.
That is a cube, and how do you know that that is a cube?
Because it
Now, be quiet. Now, one of the rules is if somebody's talking, you have to be quiet because she's saying important things that everybody needs to hear.
Because it has 6 faces.
It does appear to have 6 faces.
It appears to have 6 faces.
It is supposed to be 3D. It's hard to draw a 3D on a 2D piece of paper, so it does have 6 faces, we'll say. Go ahead. But you said it was a cube. Okay, I have a question.
Okay.
Do all polyhedra that have 6 faces, are they all cubes? Now, hang on. All right.
No.
No.
No. Good. How do you know that?
Because this one has 6 congruent faces and a rectangular polyhedron would have 6 faces, but they wouldn't necessarily all be congruent.
Very well said. It appears that all 6 faces here are congruent. It appears all 6 faces are congruent, so we could call this a cube. So not all prisms, she was trying to say rectangular prisms, are cubes, because not all prisms have all 6 faces congruent. So let me go on. So we classify these by the number and sizes of their faces, the number of their vertices, and the number and size of their edges. So let me see, who is here now? Lisa. We do have a Lisa.
She's not
You're
here.
Lisa, then you're science. This is great. Tell me a working definition for a face of that cube. Just a working definition, not a formal. A face.
Something that is visual, yes?
We have 3 labeled. It says faces right here is pointing to this, this, and that. So what is a working definition of a face?
visual, that's.
Okay. Anything else? Any attributes it has to have? Hey, wait a minute, I'll let you off.
Oh,
Denise.
it's a flat side.
Flat. It has to be flat, but she's right. Faces do have to be plain, flat. Yes, ma'am.
A flat closed plane.
Thank you. Flat, closed, plain. When you say plain, you don't need the word flat because that's included in that. So a closed, plain figure. Plain meaning flat, doesn't mean not fancy. Okay? That's one of those words between the common language and the math language that sometimes confuses kids. So plain in mathematics, P-L-A-N-E, means flat, whereas P-L-A-I-N means just not fancy. All right, so the faces are the sides, you could say, here, so it has 6 faces. Maura told us that. So let's see. Martin, can you give me a working definition for a vertex?
A vertex, corner or point of a three-dimensional figure.
Okay, corner, that's what the early people would say, PK through 2, grade 2. We call it a corner, and then you called it a point. So what forms that point?
Edges,
Okay, what about the edges?
the edges form an angle and an angle.
Where the edges do what? Intersect, yes. So where the edges intersect, it forms a vertex. And the plural for vertex is vertices. All right? So there's one more word up there, and he used it. Christina, can you give me a working definition for edges, or an edge?
Where two faces intersect.
Very well said. That's more than a working definition, that's a formal definition. So where 2 faces intersect, it forms an edge, okay? So the definition, by the way, we're up there. But I appreciate y'all not reading that ahead of time. So we talked about this, the classification. We have 3D shapes. We have those with polygonal bases, okay, polygonal. Tell me, let me see. Until I learn your names, I'm gonna have to use these. Beatrice, where are you? Right there. Give me a definition of a polygon. We know what poly means.
Poly, a shape of
Many, right?
their pose.
Yes. So a polygon has, is a closed figure that has many what? Polygons are flat, by the way. Good. Many sides, okay? And I don't know if y'all noticed, but the question I asked her was really a very poorly worded question because I ended with like a fill in the blank. Did y'all notice? What did I say? What was my fill in the blank? As many what? And when you do that, then your students are playing this guess what I'm thinking game. Okay, what does she want me to say? And they may not know. So you should not ask those fill in the blank questions. It's very hard to break that habit, and obviously after 44 years in education, I have not done that yet. Because they do sneak up on you. So try very hard not to ask those fill in the blank type questions. All right, so anyway, back to this. So we have a polygonal bases, which are pyramids and prisms. That's all we really need to know. There are more, but these 2 are the ones we're working with. This is all from last summer. We have circular bases, which are cylinders and cones. And then the sphere has no base at all. When I was at camp, I specifically asked the math person, I went to the TEA session, and I specifically asked the math person about cylinders. Here, this is a cylinder. Okay, I think I'm going to wait and let y'all figure this out for a minute. Never mind what I was just saying. Okay? Yes, it's a teaser. So, this right here could be called a triangular pyramid. Brenda, why could it be called a triangular pyramid?
It has a base.
What shape is the base?
Base is triangle.
Good. And that gets the triangular part. The pyramid,
It only has one base.
it has one base.
And a vertex.
Okay, and the lateral sides are
Triangle.
triangles. Good. So it has a base. This one happens to be triangular. And the lateral sides, the sides going up to the apex, are triangular, okay? And this also has several names. We could call it a cube because it is, all the faces are congruent. We could also call it a rectangular prism. We could call it a hexahedron, or as some people call it, a rectangular parallelepiped. Okay? So if you're reading in your books, you may have any of those names at all. So this one I'm interested in, hexahedron, hexa meaning how many, Brenna?
6.
6, and hedron meaning, let's see, Ashley.
Faces.
Face.
A face, right, hedron means face, right, so 6 faces. I feel like I need to hurry. So here are some common definitions, and these are not the definitions that you will find every source that you look at, but these are formal definitions, all right? So for a prism, it's a 3-dimensional shape with 2 parallel and congruent polygonal bases and rectangular lateral faces. And there is an example of a prism. So let me see. I've got to learn your names because I really don't like doing this. Donna.
Dawn's not here anymore.
Donna's gone. Okay. Denise. Sorry, I already called her Denise. That's okay. I lost track of the question. We're looking at the prism.
Yes.
Which faces are the bases?
The 2 ends.
The 2 ends, what color?
They're blue.
They're blue. And what shape are they? Yes, they're pentagonal. So this would be called a pentagonal prism. Now, why are those the bases? And I'm still going to go back to you. You were very certain in your answer.
Yeah.
Get it?
I'm thinking because you could stand it. It's where you could stand it up.
It's standing up right now.
There it is.
That was a bad answer, wasn't it?
Can I phone a friend? Ask her a question, Martin.
Well, if you're correct and you said it was the blue, how would it look if you stood it on? What would be different how it's standing on the blue versus how it's standing on?
Would it be taller?
What about the